Good morning. My name is Dr. Rebecca Deans, and this is my distinct honor to be your virtual moderator today for the Stephanie Mulkey keynote speaker session, Science of Pain, at the 17th Annual SCD Educational Summit. Oftentimes, sickle cell pain is not well understood, and the patient's pain is dismissed or minimized. There are a myriad of social and historical reasons for this that still reverberate throughout our sickle cell warriors' lives, affecting how their pain is managed. During today's session, we will be discussing the science behind pain, specifically sickle cell pain. We'll be looking at what sickle cell pain is, how sickle cell pain occurs, and how it differs from other types of pain. The speakers today will unpack the history, the pathophysiology, and types of pain, acute, chronic, and neuropathic, through interactive discussions and live polling. Together, we will learn how pain is experienced uniquely by each sickle cell warrior and why personalized treatment really matters. At 9:15 a.m., Dr. Saranya Valuswamy will talk on the pathophysiology of pain. At 9:45 a.m., Dr. Madhu Visa will speak on what is pain, a history. Oh, sorry, they said Dr. Madhu Visa will be next, so she'll be the 9:15 speaker, and she will be speaking on what is pain, a history, and then I believe at 9:45, Dr. Saranya Valuswamy will speak on the pathophysiology of pain. At 10:15 a.m., Dr. Amy Patel, Jackie Carter, MSN, RN, CNS, Trenacia White, Herb Carter, Jay Snow, and Angela Woods will discuss defining and treating acute, chronic, and neuropathic pain. And 11 a.m., we'll be wrapping up our discussion. As you just saw, I'll be keeping my eye on the webinar chat. We do have questions, and we can jump in. We have time to jump in. I'll be letting our panelists know so that we can have your questions answered. Thank you so much for letting me be your moderator. Thank you so much to Kian Wellness. And I'll be giving some extra time back here so that we can start our program a little bit earlier. Thank you so much.
The topic that I was asked to present on today is sickle cell disease. What is pain? A history, which who knows why they chose me to talk about this. I'm relatively new to the field. I've been doing this for about 5 to 6 years. And learning about this topic has really humbled me, because I think that, when you're knee deep in the trenches of taking care of people with sickle cell disease, kids and adult, it's really easy to feel like you know what you're talking about, you know what the current status is. And, I've seen an evolution in the several years I've been doing this, but to look back in history and look back over the last century and beyond about how people with sickle cell disease have been treated, it's just been incredibly humbling for me to know how far we've come in such a short amount of time and really what it took to get here. So as I said, my topic is what is pain, a history? And I think that this is a nice place to start as we progress into the talks by my colleagues who are going to be talking more about what we know currently about pain. It's amazing to know how we got here. And again, my name is Madhu Visa. It's nice to see you all. Thank you. Do I control the slides here? Okay, I have no disclosures. Nobody pays me anything. I don't know if anyone's used ChatGPT as a tool to create images. I put in a couple of keywords. I put in sickle cell, pain, history, and this is what it gave me. I think it really is kind of compelling, showing these aspects that even an AI generator can kind of tell. It describes a long history. It describes this kind of oldness to this condition that's been around for millennia. It describes the biology, but also the feeling, and this really central aspect of suffering, which you can see in this man, AI-generated gentleman on the left side. It also describes just how abstract it is, right? I think I had an image in my mind of what I was looking for when it came to, a scroll or something historical, but there's really nothing to encompass just what this experience is like, right? There isn't a paper that describes a history. This is a human experience, and this is a personal experience that really can't be written down anywhere. So I'll do my best to describe how sickle cell has been described in the literature, and how it's been described in our communities, but just to note that it's a little bit hard to find this information because it hasn't been documented very well. What has been documented is going back, centuries before the 1900s. This is a condition that is not new. That it's been known in many, many African cultures and in different tribes. I will not embarrass myself by trying to pronounce these incorrectly, but you can see here a lot of these names have a kind of onomatopoetic feeling to them. They sound like something. They have a lot of repeated words. And what I learned is that many of these phrases or words actually convey the pain and suffering that people are experiencing. Nobody knew what the blood looked like, right? Sickle cell disease is a description of the blood cells under the microscope. It has nothing to do with the patient's experience. But all of these words describe suffering, describe pain, describe the noises that people might make when they're feeling the misery of living with the pain crisis. In the 1800s, there were some people who investigated, just were curious about some individuals who, on autopsy specimens, either had recurrent fevers, had an absence of the spleen, had recurrent joint pains that were worsened by the rainy season. This is a picture of Mr. Horton, who was an anthropologist, I believe, looking at some individuals with these kind of unusual symptoms in West Africa. But really, it hadn't been described with any seriousness other than a couple of cases, a couple of autopsy reports. And I think that this is a good time to talk a little bit about sickle cell disease in Africa, both in the past as well as now. It's really not well studied or documented. There's very little said about it. And a lot of times the symptoms were mistaken for other tropical diseases, in particular malaria. And so there is a large overlap between sickle cell disease symptoms and many other conditions. And so sickle cell wasn't described as this unique separate entity until much more recently. Another thing is that a lot of people didn't survive childhood in order to describe sickle cell as an adult condition. And so it really didn't receive medical attention in Africa or really anywhere. And then in some cultures, I think this is really key, sickle cell disease was thought to be a curse or some sort of judgment from the divine. And I like this Venn diagram that's shown here. This is actually from a very recent article that was published looking at stigma and the impact of stigma in sickle cell disease in Africa to this day. Kind of combining the aspects of stigma, pain, sickle cell disease, and how they all overlap to cause really a highly variable overall burden for people with sickle cell, including things like social exclusion, emotional impacts, and healthcare burdens. I wish this was a slide describing what things were like centuries ago, but this is a slide describing what things are like now, not just in Africa, but probably worldwide. And I don't mean to read this out today, but it's really describing that some of these challenges still persist both amongst community as well as healthcare providers, that there is some progress when it comes to how we perceive sickle cell in the medical community, but in the community, the stigma level is still quite high. There's beliefs linking sickle cell to breaking taboos, or that there's a curse for ancestral sins, often viewed as a spiritual affliction. I think I read about one culture in which a family was believed that every fourth child was meant to be well, and of course that correlates with the genetic inheritance pattern of sickle cell being an autosomal recessive, for two parents with trait having a 1 in 4 chance of having a kid afflicted with sickle cell and a kid afflicted with no trait. And so I just wanted to highlight that the history is one of progress, but certainly the challenges persist today. And then, of course, we can't talk about sickle cell disease and its presence in our communities without talking about the slave trade in centuries past. So mostly from West Africa, there's some people call it the slave coast, with a lot of migration from Africa to the West Indies, to the Caribbean, and to North America, where now we have sickle cell appearing in our community. As we all know, sickle cell was, if people evolved sickle cell disease in order to fight malaria, and in the US we don't have malaria. However, the genetic condition has persisted, and it's going to be several centuries before it evolves away because of the lack of malaria parasites in North America. This brings us to a young dental student named Walter Clement Knoll. He was born in 1884 in Grenada in the Caribbean to a pretty wealthy family. And they were wealthy enough that he was actually able to pursue a good education and travel to the United States to study his dream of dentistry in the early 1900s. It is written that he was frequently ill as a child, that he developed a severe leg ulcer on his journey to Chicago where he was in dental school, but it was never really described why he was ill or sickly. When he was a dental student, one of his mentors, Dr. Herrick, did notice that he had several episodes of fatigue, severe pain, and some respiratory problems. And so they investigated it with some interest. Dr. Knoll completed his dental school and returned to Grenada, where he was a practicing dentist, but unfortunately did die at age 32, probably due to acute chest syndrome. And this is a photograph of his grave, which is now a commemorative site. This is Dr. Herrick and actually a medical intern, a first-year resident named Dr. Irons, who doesn't get any credit for his work on this in the publication, but this is the first publication describing sickle cell disease, and I think that this is a cool picture. I believe this is actually a drawing that Dr. Irons did, and it was entitled Peculiar Elongated Sickle-Shaped Red Blood Corpuscles in a Case of Severe Anemia, the first description of sickle cell disease in the medical literature. I think that it's really easy to consider that this might have been the start of an era of progress in sickle cell, and perhaps it was. But it's important to know that this is the first description of sickle cell in the United States, or at least in the Western world, after it's been present in the Western world for 400 years or more, after its arrival in the United States from Africa. Most literature in this early time, which isn't that much, really describes just the objective features of the condition. It describes anemia, it describes respiratory problems, it describes severe episodes of pain. It has really very little description of the impact of pain on the individual. The term crisis started to be used early on in the 20th century, but it was really sort of used as a kind of derogatory term. There was a lot of mentions about how it demonstrated racial inferiority, that it reinforced some of these race-based judgments of individuals of African descent. It was really initially thought only to affect Black individuals, and this is a paper in 1922 by Dr. Mason. He said, he reviewed 4 case reports and said, this must only happen in Black people, despite it really only being 4 case reports. And the thought was that Black people were biologically predisposed to illness and suffering, and so it really didn't make sense to people that anybody else could have this condition. In fact, when people with lighter skin presented with the same symptoms, there was a lot of consideration that maybe this person was secretly Black or they had Black ancestry, and there was a lot of judgment associated with that. An ongoing issue is that pain was continued to be considered an episodic and very secondary aspect to the hematologic parameters that were being seen. Pain was not an important part of the disease, it was just something that was also there. And you'll see this as a theme. I'm going to say this a couple more times as we talk through the decades. And then, of course, in this time was Jim Crow America, where the suffering of Black people was really often very discounted. I'll read this out loud. Sickle cell pain thus became an example of a broader cultural pattern, disbelief in Black pain. And so people often endured crises at home. They felt hospitals were hostile spaces, and I wish that this no longer was the case, but I worry that it still is. And it contributed to the invisibility of daily pain in the medical records. There are some early descriptions of pain as a narrative, and again, there was only 4 case reports up until 1920s, and many of the narratives do describe some of these aspects of pain, but oftentimes they refer to people as being sickly, as being unable to attend school or work, really not really empathizing or sympathizing with patients, just kind of demonstrating their weakness and their inferiority. A couple of descriptions here. The pain occurred in paroxysms lasting an hour or 2, coming 4 or 5 times daily, and leaving with distinct soreness. It radiated to each side of the abdomen and was accompanied by persistent vomiting. You know, we do try to be objective about our assessments, not try to attribute some feeling or emotion, but there's a little bit, you can go a little too far on that, and sometimes only focusing on how what the patient's symptoms are really kind of minimizes the impact and the emotional suffering. Another one is the pain was practically continuous and excruciating pains in the legs, requiring frequent injections of opioids daily with only partial relief. Just another example of how objectively pain was described without referencing the emotional impact. Dr. Diggs was a pathologist in Memphis, Tennessee, and I think that he was an important figure in sickle cell because he was the first to actually describe the impact of organ damage in sickle cell disease and noted that pain was a result of cells blocking blood flow. I think at this time there was a pretty rapid evolution in the understanding of the medical literature, showing that oxygen was important for organ function, and describing that the impact of pain from blockage of blood flow could also be correlated to organs, I think was a really important discovery. Dr. Diggs was also the first person to describe the difference between sickle cell disease and sickle cell trait, and sort of opened the door to understanding that many, many people actually carry the sickle cell gene without actually having sickle cell disease. This was really pivotal work that oh, there's a dog here, how cute. There's really pivotal work suggesting that sickle cell was a systemic disease, which in my mind, I was reading this and thinking, hey, this must be the beginning of really important forward progress, but it surprised me that we're kind of stalled here. And I wish that I could say that this understanding of a systemic illness was a catalyst for something, but I think that the way Dr. Diggs initially described it, despite having really important contributions to the field, it really did continue to reinforce the racialization and minimize the chronic nature of this condition. In the 1940s and 50s, this is when the discovery of DNA and molecular medicine was at its forefront. And sickle cell disease is often described and is the first molecular disease. This is the first disease that was described by its molecular basis, looking at the exact mutation and the exact protein that was affected by, that causes the mutation in hemoglobin. Linus Pauling was the one who discovered that sickle cell disease was due to an abnormal hemoglobin, and then Dr. Ingram in the 1950s was the one who discovered that this was a point mutation in the hemoglobin gene. There was also a growing understanding about the link between sickle cell and malaria that helped to inform some of the epidemiology and also sort of opened the door to know that this might not affect only people from Africa, but places where malaria exists. But I think that it's, again, you hear about this and you think, great, progress. We made some moves in learning about the biology. But Dr. Linus Pauling actually said this in the UCLA Law Review. I have suggested that there should be tattooed on the forehead of every young person a symbol showing possession of the sickle cell gene or whatever similar gene that he found, that he has been found to possess in a single dose. So this is describing people with sickle cell trait. If this were done, two young people carrying the same seriously defective gene in single dose would recognize the situation at first sight and would refrain from falling in love with one another. Culturally funny that in the 60s you have to fall in love to have a baby, but whatever. I think that the sentiment at the time possibly was forward thinking that you want to make sure that people aren't suffering, that aren't having kids. But I do think that there was a background of eugenics and a background of racism part of this, saying this is a good way to eliminate an inferior part of our society. This is a way to move forward in our superior race. And whether he said it out loud or not, that really is the sentiment that is behind the statements like this. And he wasn't the only one. I don't think that this was like a shocking or controversial statement at the time. This seemed to be well accepted by mainstream culture. And I think one of the things I really picked out from a lot of the literature around this time is that pain up until the mid-1900s really was seen as this episodic phenomenon that popped up, went away, and you returned to baseline. There was really no understanding that this was a progressive and a cumulative and a sort of chronic nature of pain. That there might be some differences in the severity over time, but every time a pain episode happens, it returns to normal. And there was really no understanding of what happens outside of the acute care setting and what the lives of someone living with sickle cell looked like when it wasn't in front of a doctor. In the 1960s, I think that it started to become really apparent too that knowledge, not just amongst the medical community, but really amongst everybody, was very limited. There was an article published in a journal called Public Health Reports that noted that less than 1 in 4 Black Americans actually had ever heard of sickle cell disease, and if they were aware of it, they weren't aware that it was hereditary. So incredibly limited understanding amongst really anybody taking care of sickle cell that this was about anything about it, really. And I think that this was, I don't need to say out loud that racism played a huge part of this, that not only was there limited understanding, there was limited interest in understanding. There was a minimization of the experience, and there was a hiding away of the experience. And this really changed during the civil rights movement of the 60s. That people with sickle cell started to be more vocal, they started to get more advocacy, and they gained traction. Advocates and activists began to connect the sickle cell experience with a broader struggle for racial injustice, and fought for equality using sickle cell as sort of a good example. And this laid for the groundwork for some really incredible explosion of awareness and advocacy in the 1970s. And there's a sociologist named Keith Wailoo who's written a lot about the history and sociology of sickle cell disease. I recommend you reading any of his articles, or he wrote a book called Dying in the City of Blues, talking about the history of sickle cell in Memphis, which many of you might have read or heard about. He wrote this in an article in the New England Journal a couple of years ago, saying, as a disease of pain and suffering that afflicted Black Americans, sickle cell disease became a political symbol for patients, doctors, politicians, and others seeking recognition, compassion, and equal rights. I think that this is, I'm curious to talk to any of you guys who were alive and around this time, just to kind of hear what it felt like and what it looked like to see sickle cell come to the forefront of the conversation. And a lot of this had to do with the Black Panther Party, which I'm excited that many of you were going to go to the museum. It was local. It was right down the street from where I work up in Oakland. This is a newspaper clipping from the Black Panther describing the Black genocide and sickle cell anemia. I actually read through this whole thing a couple of days ago. There's a PDF online that I encourage you to look at. And it had a really lovely medical description of sickle cell, far more sophisticated than I would have sort of, using my own implicit biases, assumed for 1970s. Pretty much exactly kind of what I would write about the pathophysiology of sickle cell today in 2025. But it really goes on to shed light on the fact that the way that sickle cell disease was perceived in the 1970s was intended for there to be an elimination of not just people with sickle cell, but really of this race, that it was a Black genocide, a way to get rid of people who were thought to be culturally and biologically inferior. Great, really cool article. Plus, I love that they had blood cells in the background of a newspaper clipping. I think that's super cool. So the Black Panther Party and the civil rights movement were really going hand in hand. The Black Panther Party had a lot of really important contributions, both to activism and civil rights, as well as community advocacy. You've heard stories about breakfast community organizations, about sickle cell screening, about other really important health initiatives related to Black Americans. Of course, there's the other part of this about the militia and the other sort of unrelated to health advocacy aspects of the Black Panther movement, but I think that we really can't talk about sickle cell in the 1970s without giving a lot of credit to this really powerful organization that gave a voice to people who previously did not have one. The rapid increase in awareness was really palpable in the across the country, and the Panthers really directly accused the government and the medical establishment for their indifference to Black pain. I say indifference here, but I think I probably mean their open sort of hostility towards Black pain. By naming this neglect, they really started to validate the experience of patients and started to really name this disbelief that the Black pain was a real thing and that these patients deserved care wherever they were seeking relief. And as a result of this, widespread screening became more common, not for the purpose of eliminating this population, but for the purpose of educating them and setting expectations for what life could look like. Until now, pain was perceived as this sort of secondary alternative kind of aspect of sickle cell disease. In the 1970s, it evolved to some extent to be perceived now as a civil rights issue, as kind of a clear way to describe why Black people were not being treated fairly. I love this picture. I think that this picture might have been like color added to it, just because I found black and white images to it too, if anyone has seen this, but this is a demonstration of one of the Black Panther community events doing widespread screening. I think a lot of this happened also down the street from where I get to work up in Oakland today, which I find really cool. And this rapid advocacy actually led to government action. President Nixon said this in a statement to Congress. It is a sad and shameful fact that the causes of this disease have been largely neglected throughout our history. We cannot rewrite this record of neglect, but we can reverse it. To this end, the administration is increasing its budget for research and treatment of sickle cell anemia. And he signed the National Sickle Cell Control Act in 1972, which, again, I hope would make a much more rapid impact on the progress made in sickle cell. It certainly made a big impact, but it wasn't as powerful as I would have hoped looking forward into the future. But it did establish what we now know as the sickle cell cohort, about 4,000 individuals through centers across the country, which is probably one of the most important natural history studies that we've done, understanding the role sickle cell plays in the lifespan of somebody born with this condition. Dr. Charles Whitten was a pediatric hematologist who was based in Detroit, and he was one of the first providers who really shared this widespread understanding of the importance of screening, such that by the 1980s, screening really became much more common in every state. He founded the National Association for Sickle Cell Disease of Michigan, which then later expanded to a national organization. It's now called the Sickle Cell Disease Anemia Association. And he led that organization for 20 years, both from a medical advocacy standpoint as well as a patient advocacy standpoint. And in 1971, he organized the largest group of community-based sickle cell disease organizations anywhere in the world. So I think that really this is just one demonstration and an important demonstration of how progress was starting to be made. In the 1970s, pain crisis really still remained the most evident symptom, but there was some growing interest in the lived experience. A couple of cultural things that started to become more common, whereas there's a movie with Sidney Poitier called A Warm December that many of you may have seen. Bill Cosby did a thing on it. There was more writing on it. There was a Time feature, a feature that was, I think it was in a smaller journal, but then picked up by Time magazine, describing a woman's experience with sickle cell disease. And so I think that there was increasing awareness, but at the same time, in parallel, this is a little bit of a double-edged sword. The more people knew about it, the more they were able to develop some skepticism, some criticism, and some sort of different kinds of judgment on pain. So that leads us to the 1980s. This is when emergency department care and opioid use significantly increased. And providers were increasingly skeptical of patients, really calling them drug-seeking. And this is, again, in the thick of the war on drugs that President Nixon had initiated and President Reagan had continued. At this time, there were no specific treatments for sickle cell disease, despite it being well known and described for decades. Keith Wailoo also describes in another one of his publications the parallel contrast with cystic fibrosis, Tay-Sachs disease, showing that these are also autosomal recessive genetic conditions that affect different populations. And by this time, there were important advances in the treatments and understanding of these conditions. And so I think sickle cell disease did lag behind this. Thank you. There was starting to be an increasing awareness of the role of inflammation and ischemia reperfusion injury, so the pathophysiologic mechanisms were beginning to be understood. And there was some increasing understanding of the role of inflammatory cytokines, adhesion molecules, oxidative stress that were going to potentially inform ongoing progress. I didn't realize this. It wasn't until 1991 when this paper was published. It was derived from the sickle cell cohort established by the National Sickle Cell Control Act, that it wasn't until 1991, in my lifetime, that pain was described as a risk factor for mortality. I'll just read this conclusion here. The pain rate, episodes per year, is a measure of clinical severity and correlates with early death in patients with sickle cell anemia over the age 20. Up until this time, it was not considered to be a condition that shortened the lifespan or had an impact on chronic health. It was considered to be episodic, and it wasn't until 1991 that people started to believe that pain and sickle cell might actually be might be linked with organ damage and mortality. And this really opened the door for investigation and new ways to manage sickle cells, so that in the 90s, many important interventions and treatments were starting to be discovered. So hydroxyurea was published in 1995, the main paper supporting its approval, and it was approved for adults with sickle cell in 1998. There was a lot of interest in looking at organ damage, nephropathy, brain health, et cetera, in the 1990s, a lot from my mentor, Dr. Vichinsky, which I'm really lucky to learn from. And one example of this is another one of my mentors, Dr. Walters, publishing a large case series of adults with sickle cell disease undergoing bone marrow transplant as a curative option. It's the first potential cure for sickle cell. And the graph on the right here just shows mortality for people who had more crises. You can see the solid line showing that people who had more crises were more likely to die. Again, this does sort of emphasize the episodic nature and minimizes the chronic nature. Keith Wailoo published this graph on the left side in his New England Journal article showing just how life expectancy improved over time, and the National Sickle Cell Control Act was a huge catalyst for improvement in life expectancy, and then the 90s were even more important. However, when you contrast this with the life expectancy for all Americans, despite this really amazing increase in survival, it's nowhere near what age-controlled matches are for people without sickle cell, and so I think we have a lot of room to grow here. In the 2000s, again, shocking to me that it took this long, there was finally some interest and some funding to study the impact of pain. And we really started to realize there's really no routine lab values, exam findings, vital signs that correlate with pain. We can't We can't assess pain in an objective way without understanding the patient's report. And healthcare utilization was not a good way to study this either. We learned that people might not go to the ER for pain episodes due to long wait times and poor treatment. Utilization may overestimate pain episodes. There's some people who go to the hospital at different thresholds than other people. And then, of course, bias and prejudice have an impact on the way that pain is perceived as well. And this was really very clearly demonstrated by Dr. Smith and his colleagues. Is Dr. Smith here? I didn't see him. One of my idols as well, who wrote this amazing study, the Pain and Sickle Cell Disease Epidemiology Study, or PICE study. It was a cohort study that did daily diaries of pain, looking at what the experience is. And I know I'm running out of time, so I will just cut to the chase that half of Americans felt pain every day. And only about 3% of those days were seen in the healthcare setting. So what we're seeing in hospitals is a tiny proportion of the pain experience that people are having on a daily basis. Half of people with sickle cell disease have pain every day. And I think that this really led to the fact that we need to understand pain in a different way. In the 2000s, there was a lot of work done to understand the roles and mechanisms of chronic pain in addition to episodic pain. Ideas such as peripheral and central sensitization, the idea that your nerves change as a result of frequent exposure to pain, was becoming more understood. And we really started to hone in on the intersection between racism and healthcare as it starts to become part of the forefront of sickle cell disease. And so now where do we stand? Pain is clearly recognized now as a central and important aspect to the quality of life of someone living with sickle cell. We now know that multimodal pain assessment and management is becoming increasingly routine. I certainly try to do this with my patients in clinic. We now know that the pathophysiologic mechanisms are varied. There's a lot of genetic modifiers. We know that hyperalgesia, this like increased signal of pain despite what the trigger is part of the condition. And now after decades and decades of advocacy, guidelines now recommend rapid and aggressive pain management for initial presentation of sickle cell disease. I don't need to go through this. I just put this up here to show like how sophisticated our understanding is of the pathophysiologic mechanisms that I believe my colleagues are going to speak of in the upcoming talks. But just compared to even 30 years ago when people didn't recognize that chronic pain was a condition, now is what we know that this is complicated now. And ChatGPT helped me put this together too after I had a lot of conversations with it about how to put this together. It took 100 years for us to go from the discovery to personalized therapy, which is what was needed all along. And so where we are now, it's amazing to me that in the last 100 years, we've come to a position where we have a World Sickle Cell Day on June 19th. We have Sickle Cell Awareness Month. We have new therapeutic agents, transformative therapies, gene therapy, transplant. They're becoming increasingly accepted, increasingly used, and increasingly people want this for our community. It's now understood that pain management must be individualized and multimodal. And if you guys stick with me tomorrow, I'll talk to you a little bit about pain management strategies. There's a growing belief that the patient's report is a gold standard for assessment of pain. We are nowhere near where we need to be, and we're nowhere near where our patients deserve, where our warriors deserve. And so there's so much room for growth and progress. But I'm very proud to be part of this community that is working towards it. So that's where I will end, and then thank you for your time.
Oh my God, thank you so much, everybody, for that warm welcome. I'm so happy to be here. I want to extend a huge thank you to the Cayenne Foundation for letting me be here today, and for all our sickle cell warriors for giving me the opportunity to speak in front of you all. And really an honor. I really wanted to talk about the pathophysiology of pain, but also have a little bit of a different spin on it, investigating, is this really actually a phenomenon of our autonomic nervous system? So I'll go into that a little bit, and I wanted to preface by saying that a lot of this work has been done in collaboration or under the guidance of my mentor, Dr. Thomas Coates, who a lot of you might be aware. So I'm really glad to present in front of you. So I'm going to share my slides, and also I apologize that I'm not there in person. I had clinical duties that I couldn't get away from, but I'm really happy to be here virtually. So let me share my screen. Okay, I hope that looks good. All right. Okay, so I do not have any disclosures to report. So We just heard a fantastic talk about the history of sickle cell disease and pain. So I won't spend too much time on this, but we really all quite aware that this is the most common inherited blood disorder in the United States. We have over 100,000 Americans, primarily of the African American community, living with this disease, and about 6,000 here in the state of California. But as you can see, sort of by this heat map below of the number of newborns that were born with sickle cell disease, in 2015, you can see there's, in addition to a huge population in the African subcontinent, there is also quite a bit in the Indian subcontinent and in South America as well. So this is, truly a global issue. Now, what's happening in sickle cell disease? It is the molecular basis of sickle cell disease was, as we just heard, was discovered way long back in the 1950s, and it is because of a single point mutation in the beta globin gene that leads us to make an abnormal hemoglobin S. Then that leads to sickling of the red blood cells. Now, normally when you have normal hemoglobin that's kind of scattered around within the red cell, as you can see here by these little dots. But when you have hemoglobin S, when hemoglobin S releases oxygen to the tissue inside, then it goes into these polymers, or the deoxygenated form, where the hemoglobin S molecules start sticking to each other and makes these strands. And this really stretches the red blood cells and creates an abnormal shape, which is this characteristic, what we call the sickle shape cells. Now, what is so different about these sickle cells is that this sickled red blood cells are very rigid, so they're not able to navigate the red blood cell capillaries. The capillaries are really the smallest unit of your blood vessels in your body, and so they're very narrow, and normally the red cells have to kind of squeeze through them to pass through them, but the sickle red cells are not able to do that effectively. And so though they can get stuck in these narrow vasculature, and when it gets stuck there, that's when you have decreased blood flow and what we call like ischemia, and low oxygen to the tissues, and then this leads to the feeling of acute pain, and then also causes significant organ damage that kind of builds up over time, and we see all the chronic effects of sickle cell disease. Now, in addition to being these rigid sickle cell, these red blood cells that are permanently sickled, they're also unstable. I mean, they have a shorter lifespan and they can break apart sooner. And when this process called hemolysis happens, and there is release of more free hemoglobin into the circulation where it's not usually there present, and then there's also like what we call free heme or free iron that can then go on to cause damage to the blood vessel walls. And also oxidative stress. And now the red blood cells are also, sickle red blood cells are also quite sticky, so that they can stick to the walls of these blood vessels and also kind of attract more white blood cells like neutrophils and activated platelets. And so they all kind of go together to make this what we call the vaso-occlusive plug. So essentially, sickle cell disease is also very pro-inflammatory inflammatory state where you can have high white blood cells, and this can also cause potential impact on the vaso-occlusive process. Now, I don't have to speak about the manifestations of acute sickle cell disease to this population. So I briefly mentioned that, dactylitis is something that can start very early on. It's one of the first manifestations or inflammations of the digits that we can see in babies with sickle cell disease. But by far the biggest complication that I focus on today is vaso-occlusive pain, which is the hallmark of sickle cell disease that is the lived reality of our sickle cell warriors even today, and it is the most frequent complication. Acute vaso-occlusion within the lungs can lead to what we call acute chest syndrome. We know that the incidence of silent strokes and Overt strokes is very high in the sickle cell disease, and in addition, one of the other major organs that can be injured by this recurrent vaso-occlusion, at least in the pediatric age group, is the spleen. With recurrent decreased, vaso-occlusion, there's areas of the spleen that get affected, and you have autoinfarction. And we know that the spleen is the first site of where the bacteria get. Certain types of bacteria get attacked. So, not having a functional spleen increases infectious risk. So, infections used to be a big cause of morbidity and mortality in children with sickle cell disease. But thankfully, with the advent of penicillin and vaccinations, which hopefully we can keep going in the current environment, we are protecting babies from the complications of infection. But as I mentioned, I want to focus more on, we're talking about pain in sickle cell disease, which we know is, again, the most frequent complication, even though there has been a lot of advancements in kind of the disease-modifying agents and improving end organ damage in sickle cell disease, like with hydroxyurea. There's not any targeted treatment specifically that kind of get to the root of pain in sickle cell disease. Now, this is a table that I don't expect you to read fully, but this was a study that was done out of Virginia, looking at over 200 patients with sickle cell disease who kept a daily, pain diary, and it was noted the probability of pain on any given day was more than 50%. And the highest probability of pain was actually in the 20 to 30, 40-year-old age group. So you can imagine the impact on the everyday lives. What is interesting, or what is not explained still, is that there's a significant amount of variability in the experience of pain itself between patients. And while we know that there are some factors that explain why certain patients have more worse pain than others, a lot of it is not fully understood. For example, like a smaller percentage of sickle cell patients can account for, up to like 10%, less than 10% of sickle cell patients with sickle cell disease can account for over 30% of the hospitalizations that happen. So there's kind of a little bit of a discrepancy that is seen there. So some patients with sickle cell disease appear to have like a worse pain phenotype, even though their blood work and their genetic disease might actually look similar to the others. So the cause for this variability is not quite fully understood yet. Now, I want to step back a little bit and talk about, what happens with the vaso-occlusive process. How does vaso-occlusion happen, right? So this model of sickle cell pathophysiology was actually proposed by Eden and Hofrichter back in the 1970s, when they were looking at how sickle polymerization of sickle cell disease, and kind of really digging into the depths of that. So the picture that you're seeing here is what we call a picture of a capillary circuit, where you have the bigger blood vessels, the arteries, and that are branching out, making the arterioles. There's smaller ones, and then finally you have these narrow, circuits, which are the capillaries, which are the narrowest blood vessels, like I talked about. And this is the place where the oxygen exchange is actually taking place. And then you have the kind of like the venules that once the oxygen is released, and then the blood is taken back to the lungs through the venous system. Now, when you have red blood cells that are moving through the blood vessels, reaching the capillaries and releasing oxygen to the tissue, hemoglobin S within the red cell polymerizes. It takes a little bit of time. It's called delay time. And then you have the formation of these rigid sickle blood cells. Now, if the red cells are moving fast enough and you have the blood flow is going good, flowing in a normal fashion, the sickle red blood cells might actually reach the larger venules. And so there's lesser chances of it causing an occlusion within there. However, if the red blood cells, the velocity is slowed and is moving slowly through the system, then there's higher chances of of it getting stuck in the smaller capillaries and higher chances of vaso-occlusion. Now, when there is inflammation and there is adhesion or like sticking of the sickle cells to the sides of the vessel wall, then the chances of vaso-occlusion are much higher, and that's where that pathophysiology like comes in. Ultimately, with vaso-occlusion, you have reduced blood flow, ischemia, reperfusion injury, we call, to the organs and to the muscles, and then that sends pain signals which activate your pain receptors and the feeling of pain. So this is kind of the underlying pathophysiology of the vaso-occlusive process. And this is the typical course described of a pain crisis. That is a lived experience. You can see once a vaso-occlusive crisis starts, it can last for up to 10 days. But I wanted to also focus a little bit on this prodromal phase, or like the initial phase, that even before the crisis starts happening. So typically we hear over and over again from our patients with sickle cell disease who come in and were exposed to either cold exposure, or they've been swimming in the pool, they went up high to the mountains, or even anxiety, stress. All these things can oftentimes trigger a pain crisis, right? And there's also a phenomenon sometimes of numbness and tingling, or sort of an aura that ascends. It's almost that a pain crisis is coming on. That's happening like, a day or two prior, and then that is started. Then that's followed by the actual onset of pain in one area that can then migrate to another. And this is the initial phase, then followed by the established phase, which is the kind of like the peak of the pain here, which is oftentimes leading to hospitalization and complications of vaso-occlusive crises, like acute chest syndrome that oftentimes develops when you're in the hospital. This is the time when there is like high levels of inflammation as well. For pain control and all the problems that are associated with not having pain under control and pain not being recognized. So that this is happening at the peak phase, and this can last for up to 4 to 5 days, and this is then followed by the resolving phase. And this is the course of a typical pain crisis, and of course there is oftentimes deviations from that, but by far an uncomplicated VOC can look like that. One question that comes up kind of looking at this sort of vaso-occlusive process is that we know that the process of red cell sickling, of the inflammation and hemolysis, they're all happening at a fairly constant rate for the most part. But what happens in those first 1 or 2 days, like prior to a crisis? Why is it that all of a sudden that we're going into full-blown vaso-occlusive crisis when the blood work might not essentially be changing? So to help answer this question, I want to talk a little bit about our autonomic nervous system and our hypothesis as to why we think that this might be happening. Now, the autonomic nervous system is a part of our nervous system in our body that controls what we call the involuntary functions, like our breathing, like our heart rate, our blood pressure. It also supplies the little blood vessels in all over your body, like the area right before the capillaries, we call the precapillary arterioles. It's actually supplied by a part of the nervous system called the sympathetic nervous system, which when we're exposed to like significant stressors, right? And this could be having like mental stress or anxiety or fear. The autonomic nervous system, particularly the sympathetic nervous system, causes vasoconstriction, or it causes these blood vessels to constrict. So why would this matter? You would think this is the typical, flight or fight response, that when we're exposed to stressors, that your sympathetic system gets activated, your heart rate can go up, your blood pressure can go up. So the sympathetic nervous system kind of regulates that. But why would this matter in sickle cell disease, right? So whenever you're having, a vasoconstriction or slowing of blood flow in the area, it increases your chances that the sickling of the red blood cells are still happening within the capillaries, and so it ups the odds of vaso-occlusion happening. So the hypothesis that when you have this sort of like sympathetic mediated vasoconstriction or a decrease or clamping down of your blood vessels. This slows your microvascular blood flow, slows down the red cells transit, and then it can predispose to vaso-occlusion. So we actually wanted to kind of study this in a systematic manner in our lab, right? So why are we talking about the autonomic nervous system? There has actually been a lot of interest in studying the autonomic nervous system in sickle cell disease. Back in the 1970s and 80s is kind of when the interest first started. That was because there was this phenomenon of unexplained sudden death that was happening in our patients. And that was thought actually to be because of a rhythm disturbance in the heart, of a cardiac autonomic origin. And so that led to a whole bunch of studies that was looking at the sort of like EKG changes and studying what we call heart rate variability patterns that they derive from these EKG changes, and studying the autonomic balance in sickle cell patients. And it was seen that, there was definitely an imbalance that was found. There was oftentimes a sympathetic hyperactivity or overactivation that was noted. And the other thing that was also noted was this: when you're having these autonomic imbalances, heart rate variability changes, there were several studies published that also showed that these patients who had these changes actually had a higher frequency of pain crises, and they actually had more severe disease. But what was the thing that was actually connecting these phenomena was actually, has not been fully described. And interestingly, even our sickle cell trait carriers also were noted to have some autonomic nervous imbalance in their sleep. But we were specifically interested in how do these autonomic changes might impact blood flow, because that can have a direct impact on sickling and vaso-occlusion. And so this was kind of the setup that we had in our autonomic physiology lab. This was set up by Dr. Coates initially in the almost like 10 years ago now. So here we would, bring our patients who were great enough to volunteer for these studies. We would bring them into the lab, and then we would expose them to stimuli that we know were, typically it can be associated with pain crises. So short bursts of stimuli. Some of them were like actual thermal stimuli exposing to hot and cold temperatures, some pulses of pain, and then also like mentally stressful challenges. We were exposing them to these tasks, and then actually studying the microvascular blood flow, the blood flow in the capillaries, and we were measuring them on the finger on the other side of the body, like on the contralateral side. So we're measuring more of a global changes in the microvascular blood flow. And so we were measuring this using a standard, pulse oximeter that gives you the waveforms that are, the blood volume, and also with the laser Doppler technology. And at the same time, we were also studying other autonomic parameters like EKG and blood pressure and blood-brain flow as well. And we're measuring all of these using a special software system in our lab. So here's an output from a study. It looks like a bunch of squiggly lines, but I'll briefly go through it so it makes a little bit of sense. The top signal is on the blue is actually pulses of pain. You see those spikes, those are actually pulses of heat pain that were delivered to the patient. And then the next three are actually measures of peripheral blood flow. And then and the bottom two, you have the brain oxygen, brain blood flow data. So just focusing on the first set of pulses, you can see immediately that when the pain pulses were started, there is a significant decrease in the blood flow here as compared to what we call the baseline blood flow or normal blood flow. So as soon as the pain pulses started happening, there was clamping down of the capillary, the blood flow in the capillaries, which we know is not can be a good thing. And so we're seeing these, responses, pretty consistently when we're giving, the pain pulses. Now, when we look at it a little bit closer, right, we needed to actually quantify these changes if we're going to really say that it does something. So kind of looking at a blown up portion of this data here in the turquoise signal is the laser Doppler blood flow signal that this is blown up here in the bottom. Hopefully you can all see my cursor moving. But with each pulse of the heat pain, you can see there appears to be that there is a decrease in the blood flow. For each pulse, there's blood flow that's happening. So we kind of plotted this blood flow. We took each point of blood flow and plotted against the temperature, and you can see as the temperature goes up consistently, the blood flow is going down. And on the top here, you can see that patients with sickle cell disease actually had a much more greater reactivity than that of control subjects. So we're actually also studying subjects, volunteers, who did not have sickle cell disease, so we could compare the two. And you can see that the mean or average reactivity to pain is actually much higher in sickle cell patients. And not only heat pain, we were also studying temperatures across the board. So we were studying also responses to just cold and temperatures at which you actually just start feeling cold or heat. And then also at the higher end, you have the heat pain and the cold pain pulses. And you can consistently see that, it's not very obvious here, but when we look at the data, we plot out the average blood flow, we can see that when you're exposed to thermal stimuli, there is a decrease in the blood flow in green here compared to the baseline blood flow. And by far, the cold temperatures are the ones that cause the most vasoconstriction, and that is something that that is not surprising, knowing that significant cold exposure can have significant implications for your blood flow, and also for, we know that it can have it's significantly associated with increased pain in sickle cell disease. One thing that was very interesting as we're kind of looking at all these signals coming through was, and we saw this over and over again, so this is the point where we started actually applying the heat pain pulses, so the temperature started going up. But we started noticing that the vasoconstriction or decrease in blood flow actually started happening even before the pain pulses were applied. And we were like, okay, why is this happening? This is very weird. What's happening like the 30 seconds prior to the heat pain? This was the point where the person who's running the study is actually telling the patient, hey, you're actually about to start receiving some painful pulses in the next 30 seconds. And so just the anxiety or anticipation of pain caused this very strong vasoconstriction response or a decrease in blood flow. And so there's anxiety or stress seems to have a significant impact on your microvasculature or blood flow data. And the relationship between anxiety and pain in sickle cell disease has also been very well established. And again, it's not some, I think this is again a lived experience for sickle cell warriors. We hear it over again that there has been a significant event that caused anxiety or a stressful event in the family, school-related stressors. They often precipitate pain crises. But how does it do that has not been fully understood, right? There's multiple literature kind of also linking this, but I have just one of the studies that up here that looked at daily pain diary entries of 15 subjects with sickle cell, and they recorded their pain, their stress levels, their mood, and how much medication they used daily for 3 months. And then it was shown that there's stress and mood significantly affected same-day pain and how much medication was taken. And interestingly, stress actually preceded, it came before the painful episodes by a couple of days. So it actually seemed to have an association of like it could be precipitating the pain rather than pain causing more stress. It could be a chicken and egg phenomenon, but there has definitely been also data showing that pain and stress, anxiety precedes the actual onset of pain. So we were definitely interested in looking at this further. So Payal Shah, who's a research associate in our lab, she would bring in subjects and we would run what we call the mentally stressful challenges. So we had on the left, you have what we call the Stroop test. So both of these tests, the Stroop and the NBAC test that are shown up here, are very validated tools that have been around for a long time for mental stress challenges. And so in the Stroop test, you're actually supposed to recognize the color of the word, not actually read the words. Can be challenging if it's flashing at different speeds in front of your screen. So the first answer would be actually green, and the second one would be red, and so forth. And the NBAC test was a test of memory where you had to recall like certain letters that are flashing on the screen at a certain sequence. So when we did this challenge with our subjects, we saw here on the graph is a graph showing like mean blood flow data. So to the extreme left is actually normal blood flow, like the dot in the middle is the average blood flow. You can see it's up here, so there's normal blood flow, but when you have the mentally stressful challenges, there was definitely significant decreases in the microvascular blood flow. And then one of the other challenges that we did was we would tell subjects that we had a thermode attached to their arm, and we would kind of alert them, hey, you might start feeling a pain pulse coming soon, but the pain was never actually delivered. So the anticipation of pain was actually the one that caused the greatest vasoconstriction response, or the greatest decrease in the average blood flow. So this kind of definitely drew the link between mental stress and anxiety and how it might impact microvascular blood flow and in patients with sickle cell. And the other thing is that came out when we were looking at all the patterns of blood flow responses was that the way that subjects responded with the vasoconstriction was actually can be also quite variable. For example, the first subject here on the top in blue had vasoconstriction or decreases blood flow with the pulses. As you can see here, there seems to be a decrease in blood flow with the pain pulses that are highlighted, but they also seem to recover in between these stimuli. The blood flow comes back to normal, but the person in red here has this sort of progressive vasoconstriction response. As we're giving more and more stimuli, they're really kind of clamping down, and their microvascular blood flow really like clamps down. And these patterns seem to be sort of like inherent to the individual. Like there were some subjects who actually came back for different sort of like experiments, and we saw that they retained their pattern no matter what the stimulus was. So that was interesting. This is the person who has these decreasing blood flow or progressive vasoconstriction, would they be more prone for like a more severe vaso-occlusive phenotype? So that was the natural question, and that popped up for us. So far, all the changes that I have shown are just measured in the lab, right? And they look at what we're seeing in response to triggers. The known triggers, yes, they clamp down the blood flow, so we kind of established that. But how does it actually relate to actual VOC crises? So that's something that we needed to answer. Do these changes actually matter? Do they actually increase the risk of like a pain crisis? So in order to further look into this, we needed to gather more data of blood flow from our patients with sickle cell disease. So one area where we had a lot of blood flow data is actually from sleep studies, where patients would come in to evaluate for sleep apnea or their sleep quality. And so usually during sleep studies in the lab, there's pulse oximeter, the blood flow measurements are already being made. And so Dr. Michael DeBon, who's a very well-known figure in in sickle cell disease arena, he had a lot of data on blood flow from sleep studies from sickle cell patients. And so we, in collaboration with Dr. Michael Koo from biomedical engineering, we got access to the data, and Dr. Koo and his students kind of really went in looking at these blood flow patterns during sleep. So when we're sleeping, there are what we call transient arousals, where subconsciously we're like waking up, where we don't feel that, but these are what we call transient arousals. And these are actually like a phenomenon of autonomic nervous system, like they're caused by sympathetic activation, like brief bursts of that sympathetic nervous system getting stimulated. And so these are actually known phenomenon. So we wanted to study that how is these arousals that you can capture in an EEG or from the brain, how is that impacting the blood flow, and how does it look in patients with sickle cell disease. So in order to do that, we needed to sort of quantify those changes that were happening in sleep, right? So Dr. Koo and his students, they developed this biomarker where we can actually look at how many of these vasoconstriction events that are happening with arousals, and then look at how deep the vasoconstrictions or how long they're happening. And so you come up with this number that can actually like quantify how much your blood flow is going down. So for example, the first subject here, and this is a recording of a sleep study that's almost like 8 hours, looking at the blood flow of the patient and subject in blue, you can see that there's not as much changes to the blood flow patterns. There seem to be like quite consistent. And so the mVasoc, or the vasoconstriction marker, is at 5%, as opposed to the subject here in red, who has a lot of like changes in their blood flow patterns overnight and a lot of areas of vasoconstriction, and accordingly their mVasoc, or their biomarker, is high at 26%. So when we applied the sort of like biomarker to our patients with sickle cell disease and looked at how much pain crises that were happening, it came out that the higher your vasoconstriction index, then there was a higher rate of hospitalizations for severe pain crises in the upcoming years. So this vasoconstriction, or how much you're changing your blood flow, is actually predictive of the pain phenotype, of how much severe pain was happening. So that was kind of really something that helped us move forward with our next question. Now that we know that there is this vasoconstriction or decrease in blood flow, is likely a missing link that actually might precipitate the onset of like a VOC or like pain in sickle cell disease. Is this something that we can harness? Is this something that we can actually do something about? All right, so our one group that we collaborated from UCLA, Dr. Lani Zeltzer, she's actually like a pain specialist who is also very well versed in hypnosis, and so they did hypnosis sessions in sickle cell subjects, and they studied their reactivity to pain, or their blood flow changes to pain, before and after hypnosis sessions, and actually saw that hypnosis actually it actually changes the way that you react to these painful stimuli. So that was really a positive finding, and showing that you can actually do something about these blood flow changes, or this nervous system activation that you're having in response to stressors. So this is something that we want to kind of take forward to the next step. So what are the next step? How can we take this forward? We're really interested in studying this out in the real world. Like we saw beautifully in the previous presentation, a lot of the pain that our patients experience are actually out at home, in the home environment. We don't often hear about the pain as much, and really, so we needed to study our sickle cell patients while in the home environment. So we're working with a wearable device company that we can have our subjects wear at nighttime to measure their blood flow changes, and record their daily pain and stress levels at the same time. So all of this is being collected in an app on the phone. So that way we can look at the blood flow changes and see if we can developed this actually as a biomarker of like, oh, we have impending pain that's going to happen in the next day or so. And so this will actually, if we're able to predict pain in advance, is open up the window for potential interventions that we can do to actually abort a pain crisis. For example, like, is it interactive cognitive behavior therapy, like hypnosis sessions with biofeedback, or there are even medications that can actually decrease the stress response and enhance blood flow, or is that something that can be trialed to actually abort crises from starting? So that would be the ultimate goal of this work.
Hello, doctor. I'm so sorry. We are almost out of time.
Oh, I'm sorry. Okay.
No, that's okay. That's okay. We do have in-person doctor and virtual doctor. We would like the attendees to ask questions, and so we want to make sure that they have time for that. Is it okay if we stop your presentation right here?
This was going to be my last.
Well, I need you to finish it. Go ahead.
No, that's what I was going to say, but I've so far focused on vaso-occlusive pain, but I just want to say not all pain is equal, and we have upcoming sessions. We'll talk about chronic and neuropathic pain, which are big components of pain in sickle cell disease. And I just wanted to end by saying that the relationship between anxiety and pain and stress and pain in sickle cell is very real, and there might actually be real physiologic changes that are happening in the body in response to these signals by decreasing the microvascular blood flow, causing that actually causes vaso-occlusion, pain, and it's sort of like a vicious cycle. And hopefully this is something that we can harness, that we can interrupt this cycle by being able to kind of predict these blood flow changes and doing something about them. So that would be the goal, and hopefully have a positive impact on pain and sickle cell disease. And with that, I would like to acknowledge the whole team, my mentor, Dr. Coates, and all the teams, all the collaborative members. And I know we're out of time, so I'll stop there. Thank you so much for this opportunity.
All right, a round of applause. Thank you so much. All right. And so if we can get you to come up, doctor, to the podium. Doctor, yes. If you guys have any questions, please come to the mics right here. You can ask questions to both of our doctors. We'll give you about 5 to 10 minutes, and I'll be back on the mic if you're too long. All right, let's go.
Hey, this is, either one of you guys can answer this question, but I was wondering, does the
advocacy and
hand swelling.
Welcome to today's general session.
Does that only happen in pediatrics?
Give me a second. Let's start right over. I want you to come a little closer to that mic. Yes, I do.
A little taller than me.
There you go.
Okay, so the hand swelling, the feet swelling, does that only happen in pediatrics and kids, or does that also happen in adults?
It can happen in adults for sure. I think any time that you have the vaso-occlusion that can affect affecting the digits, it can happen in adults for sure. But it is one of the classical first signs that we might see in children in pediatrics. So we educate our families about that. Even the first time that we start seeing them, that was one of the common sites that can affect children too, and it's more obvious in babies too.
Okay, thank you.
Hello. Okay. I do want to comment that the swelling in adults could be related to a vaso-occlusion in the hands and feet, but there might be other explanations too. And I think it's really important not to sort of, for any symptom, say like, oh, that's just their sickle cell disease, right? To make sure we're exploring other alternatives. One of them that I think is really worth noting is after a long-term exposure to opioids, sometimes there's just an abnormality of the blood vessels that leads to kind of leakage and edema and swelling.
Right.
And so I'd hate for people who have swelling to say like, that's just sickle cell vaso-occlusion and not really explore further.
Right, because it really only happens when I fly or when I'm in severe crisis.
Right. So, I mean, then most of us, when we're on an airplane, will get a little bit swollen, right?
Yeah.
But it can certainly impact health and safety during flight, which is why we're going to nag you to kind of hydrate well, walk around, and take good care of yourself. Use your oxygen on flights and stuff like that.
Right, okay, thank you.
Hi, Adrienne, Access Advocacy. I just want to thank you for putting that historical context in. I think that it's very important. Yes. It's very important for us to know the history, but not only the history, but to know the time frame. Because part of what happens is we, especially as Americans, our concept of time, I mean, especially in California, right, 100 years is old. And so I think informing people of that history, and also in talking about how our families in early generations dealt with it. In my family, I know I'm fifth generation, but I know that by the stories, right, of things like, oh, he would just lay down and he'd say he was tired, or she was book smart, not physically smart. And so I think the other thing about it is it also gives us a feeling that comprehensively, meaning in our lives and in our bodies, it's not just the pain, it is the fatigue, and reminds everybody that it's a whole thing. But so thank you. And I was laughing at the thing where he was talking about the person having the fits of fatigue and vomiting, because that was one of the things that came up so much when Sick Cells did our quality of life, and everybody was talking about pain, and all the warriors and the families were talking about the fatigue and the inability to be in their lives. So thank you, and spread that for us. Thank you.
And I'll just comment, 30 years ago, we would have never seen the work that Dr. Velaswamy is doing, right? It's just amazing where we've come.
Yeah, that was the other thing I would say, that when I started with the stem cell stuff, they said it'll never happen, it's going to be 20 years. I said, no, we'll have something by 2025, and we had it by 24. And so we need to be really mindful of how quickly things are moving. Yet the human part is very difficult to change, and this will be part of it. Thank you.
Thank you.
Okay, I have a question. First off, I second what she said. I really appreciated the history lesson with that, and just understanding who was pivotal at what point and for what reason, especially even the Black Panther information. Like, that was really dope too. I did have a question that pertained to that era, where you highlighted how their advocacy in vocalizing what was going on with Black people and sort of tying it to racial ties during the time helped ignite, like, I don't know, just sort of an information boom about sickle cell during the 70s. Like, that was a seed planted in the 60s that boomed in the 70s, and it grew from there to what it is now. What do you think, if anything, could be the next boom for that to take it to another level?
Oh, that's a really good question. I mean, I think that there's a lot of things that could be. CRISPR is like the buzzword of the last several years, right? And gene therapy, gene editing, this kind of excitement about curing diseases, whether it's sickle cell or something else. Sickle cell is such a low-hanging fruit for a genetic condition. It's amazing to me. 1 point mutation that causes this entire thing that we're talking about, right? I think that the scientific excitement is really motivating people. I don't know, even since I started, when we went to our big meeting, the American Society of Hematology meeting, with my first year, there was like one session on sickle cell. Now I have to kind of choose between multiple sessions at any given time because there's so much excitement and so much interest and so much progress. Anything from Dr. Velaswamy on that? Is she still here?
Oh, I'm sorry. Was there a question?
No, that's okay. If you don't have a comment, that's okay.
Oh, no, I'm sorry.
Hi, my name is Lee April. I'm a caregiver. My name is Lee April, and I'm a caregiver. And so thank you so much for all the information both of you have put into your slides and everything. I was taking pictures back and forth. But my question is, I've heard over the years that my son is like 22 years old. He suffers from sickle cell, SS. And I've heard somebody refer to sickle cell as being a stroke disorder. Would that, what are your thoughts on that?
It being a risk factor for having a stroke?
No, not a risk factor, a stroke disorder, because, if you think of a stroke, it stops the blood flow to the brain, but just in sickle cell, it happens all over the body or wherever blood flows.
Yeah,
So-
that's a really interesting way to frame it, because a stroke is basically like occlusion of blood flow in the brain, and it's happening everywhere all the time in someone with sickle cell. I've never heard it described that.
Yeah, me neither, and I thought that was really unique to consider it that way, and I just wanted to hear your point of view on that.
The one thing I'll comment on, and it might have been spoken on some other sessions, is just what we use to describe the experience. We're actually moving away from saying vaso-occlusive crisis and just saying acute pain crisis, calling it what it is. We don't know that vaso-occlusion is always the cause of pain, and oftentimes it isn't. You can look at the blood vessel and it'll be completely clear, but the nerves are impacted, the organs are damaged, and the tissue is hurting regardless of whether there's blood flow or not. And so I think that is an understanding that really I assumed would have been known for a long time, but it wasn't, and it isn't. So the way that we talk about it is really important.
If I can, comment about, the stroke question a little bit. The one thing that we kind of seen time and over again is the awareness of, there's not as much awareness about the risk for stroke for sickle cell patients. We've seen patients who would go in with stroke symptoms to outside hospital and the smaller community hospitals, and they would be treated as any other patient who comes in with a stroke with attempts to try to open up the blood vessels. And the first thing that we should be really tackling in sickle cell patients with in any stroke symptoms would be like an exchange transfusion. So it's kind of heartbreaking. I don't know if I have a solution, but it's just something that there has to be more awareness about how stroke can happen in sickle cell disease, and how the treatment is completely different than a stroke that occurs in a patient without sickle cell disease, and the treatment is quite emergent. So making the provider known about that, because the provider in the ED might not actually be aware of that. So having good communication and advocating, I think, is key.
My name is Gladys Hubbard, and my question is for the doctor on the screen. When you was talking about your research, could you tell us if the patients that you was following, how long they've been off their medication when you was taking this, or was they still on their medication, and was that factored into your study, and the type of medication would that have effect on the studies that you was doing?
That's a really great question. Thank you for bringing that point up. There were a lot of our subjects who actually participated on the study were actually on hydroxyurea, which some were also, not on there. We actually didn't find a big difference between the two about how the blood flow reactivity happens. Now, hydroxyurea has an impact on a different part of the pathophysiology, I would say. Like, it does definitely help in the sense that it delays sickling. So it's protective in that fashion. But in terms of actually impacting the blood flow changes that we were studying, there was not a significant difference that we noticed. But overall, one thing that did come out was with patients who are taking hydroxyurea had overall definitely less pain episodes.
Wait just 1 second before you begin. This is going to be our last question. And if you can do me a favor and make sure that mic is in front of your mouth.
Okay. Hi, I'm Vernell. I am an auntie of eight nieces and nephews, and 3 of them have sickle cell disease. I'm wondering, are parents getting tested regularly, or what way are they doing to prevent sickle cell disease if you don't know you have traits?
That's a really good question, and I think each clinic probably has their own approach. We do have a genetic counselor who is embedded in our clinic, and we're really lucky to have her speak to families about, I hesitate to use the word risk, I use the word chance, because my perception is people should have kids whenever they want to have kids with whoever they want to have kids, right? And we have good ways to take care of people with sickle cell. I, of course, don't wish suffering on anybody, but I do wish excellent care for anybody. And so if a family has a kid with sickle cell disease, our state actually does do parental testing or offer parental testing. And so it's actually funded by the state for parents to go after the newborn screen to get their own testing done. I don't know how other states manage that, but it should be done for genetic counseling purposes, not for the purpose that they should not have children forward, but for the purpose of knowledge and education.
Thank you.
I like the way you put that. That
Thank
was
you.
really nice.